All right, so this is lesson 4.3a. This is for our Wednesday, Thursday block. There's going to be 7 examples for us to take a look at. We are going to be solving the system of inequalities today. So that's what we're working on, system of inequalities. Yesterday, or the video prior to this, we did a single inequality where we learned how to graph it, where to shade, all that kind of good stuff. Now we're going to do a system of them. So the first one is, the first problem is y is greater than a negative 1/3 x minus 2. And the second inequality in this system is y is greater than 2/3 x plus 1. The first thing I want to do is I'm going to label each one of them. And I'm going to label this one A, and we'll label this one B. And the reason why I'm going to do that is when we go to graph them, I want you to see which line is A and which line is B, so we can see the differences and where we are. Because the goal of this is to find the solution that is going to be for both inequalities, or this system of inequalities. So the solution that satisfies both inequalities. So the first thing that I'm going to do is I'm going to graph. Well, I see that I have y is greater than a negative 1/3 x minus 2. Well, that minus 2 tells me that the y-intercept is a negative 2. And I am just a greater than, so I'm going to go ahead and have an open circle. We talked about the open circles and closed circles. It's going to be an open circle. And then I have a slope. The slope is a negative 1/3. So down 1 over 1, 2, and 3. You know, I could pick a point on the other side of it by going up 1, but to the left, or to the negative 3, 1, 2, and 3. And there we are. We know that we're going to dash the line as I go through, dashing the line, because it's a dashed line because it is just greater than. I also know that I want to be above the line when I go to shade, but I'm not going to shade yet because I'm going to do it after I get the other line on the graph. The second one says y is greater than 2/3 x plus 1. So I know that the plus 1 is my y-intercept, so I'm going to have a point right at 1 on the y-axis. My slope is 2/3, so up 2 over 3, down 2 over 3. And I know that I have a dashed line as well because it is just greater than. And so here we go. Draw a couple of arrows on my last dashes, and I am done. But I'm not done in the sense that I haven't shaded yet. I know that I want to be above this line since it's greater than. So line B, that as I labeled it, needs to be above. Right? And then for line A, which was in black, I need to be above as well. So I'm going to be above this one, which is greater. And all of a sudden, you see where it's double shaded, where both the blue and the black together. That is going to be our solution. The area that's both colors shaded is our solution area. So all of these values, all of these points on the graph will be points that make our inequality true. This is where the section would make it true. We know we could test it by putting in one of these points. So I could put in x is 0 and 4, the point 0, 4 in. And I could put it into both of those equations, both of these inequalities, and prove that it is a true statement. So let me go ahead and do that. I'm going to put in the point 0, 4. Well, y is 4 greater than a negative 1/3 times 0, because x is 0 minus 2. Well, 4 greater than a negative 1/3 times 0. Well, that's 0. So I'm left with this negative 2. Is 4 greater than negative 2? Well, yes, it is. So I know that it satisfies the first one. The second one, y greater than 2/3 x plus 1. So let's plug it into that one. Y 2/3 x plus 1. And that is greater than. Plug a 4 in for y. So that's a 4 greater than 2/3 times 0 plus 1. Well, I know that that's still a 4 greater than. 0 times 2/3, well, that's 0. So all I have left is 1. Is 4 greater than 1? It is. So I know that this point, 0, 4 in the graph, which is right here, I can tell you that that's a solution. Normally I use the point 0, 0, but 0, 0 would have been good for one of them, but it wouldn't have been good for both of them. I wanted to check to make sure it was good for both. So that's why I picked the point 0, 4. All right, let's move on to example number 2. I have y is greater than a negative 2/3 x plus 3, and y is greater than 2/3 x minus 1. I'm going to label them again, A and B, and I'm going to graph. I'll graph B first since I had the blue pen in my hand. -1, I'm an open circle at -1, so I'm just greater than. +2/3 is my slope, +2/3, down 2 to the -3 gives me my other one, dash line, bingo. I'm going to be greater than, so I know I'm going to shade above the line, but I'm going to do that here in just a minute. Graph the second one, or the first one in this case. Line A is how I labeled it. Line A, +3 for the y-intercept. This time I'm at -2/3, so I'm down 2, but over +3. I could be up 2 to the -3, and there would be my points. Dash the line, dash, dash, dash away. Not Christmas time yet, since we're still in October, but you get the reference, dash, dash, dash away. This one is greater than as well, so I want to be above this line. So I'm going to shade above this line. I'm going to shade above the black line. Boom. Well, the other one was greater than as well, so I want to shade above this line. So I'm shading above the line, shading above the line, shading above the line. Where it is a solution is where I have both colors shaded. I'll do it in red so you can see it. This area right in here, all of these points on the graph satisfy or make this system of inequalities true. True statements. All of those points. Once again, I could pick a point and prove it, show it, but for time-wise, we showed the last one how to do that, so you can do that on your own. Okay? Moving on to number 3. Y is less than or equal to 5x plus 2. Y is greater than x minus 2. Go ahead and label them again. A and B. B. Y is greater than x minus 2. -2 on the y-intercept. My slope is going to be 1 over 1 because there's the 1 in front of the x. We don't write it, we just write x, but we know out in front of that x is a 1. So that's 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. I know those are open. I'm going to dash. And I want to be greater than. So I'm going to be above the line when I shade, so I can shade all this above it. I'm going to wait until I have the other one. Let's graph line A. This time, I have an equal to bar underneath. So therefore, at +2, I can have a closed circle. And my slope is 5. 5. That is written as rise over run is 5 over 1. Well, I can't really go up 5 because I'm at +2. That would be at 7. So I'm going to have to go down. 1, 2, 3, 4, 5. Since I went down as a positive slope, that means I have to go over or to the left 1 as well. Those are the only 2 points I can get on this graph. So I am going to have to draw as straight as line as I possibly can and go up that way. Now this one is less than. So I want to be below the line. Below the line. So as I look at this, let's do line B. That one's a little bit easier for you to see. That one's greater than. So let's do the greater one. You can see that one because I need to be above the line. Above the line. All that. Now, let's think about this. I am less than, so I want to be below the line. Well, where is it going to be below the line? Would it be this way? Would that be above or below? Hopefully, you're seeing that it's going to be below this way. So, it's going to be down here. Okay? Which means it's also right in here. This area right here is where our solutions are going to be. Okay? This is where our solutions are going to be. This area right in here is where the solutions that would satisfy both of these inequalities. Okay? You can always check it. You can check it by plugging in the point 1, 0. 1, 0 for both. So this one is a little bit more difficult. Let's do that. 1, 0. Plugging it in for both. 0 in for y, the first one, less than or equal to 5 times 1 plus 2. Well, that's 0 less than or equal to 5 plus 2. So that's really 0 less than or equal to 7. Is 0 less than or equal to 7? Well, sure, it's less than 7. So we know that works. Let's do it for the other one. 0 greater than 1 minus 2. Is 0 greater than 1 minus 2? Well, 1 minus 2 is negative 1. Is 0 greater than a negative 1? Well, yes, it is. So we know that the point 1, 0, which is right here, right there, we know that is a solution that makes both of these inequalities true. So we know that this is accurate. All right, moving on. Before I move on, always a reminder to you, if I'm going too fast for you, please pause it. Slow it down, rewind, do whatever you have to do to make sure that you stay with me, understanding everything we're doing. Okay? Number 4, y is greater than x plus 3. Y is less than or equal to negative 5x minus 3. I'm going to label them A and B. And I'm going to go ahead and graph them. All right. Y is less than or equal to negative 5x minus 3. Open circle at negative 3. My slope is at negative 5, which means negative 5 over 1. I can't really go down 5, so I'm going to have to go up 5. 1, 2, 3, 4, 5. But the negative means I have to go to the left. Since it isn't equal to, I am going to close these circles. And close these circles. Okay, so these points on the graph are going to be closed. Those are awfully big points on the graph today. It is going to be a solid line because it has the equal to bar underneath. So solid line. Points are closed because it is going through those points. Okay? And so there it is. Less than. I want to be less than that, so which means I have to be below the line. We're going to do that here in just a second. Let's graph the first one, or line A. Positive 3, but it's a just greater than, so it is an open circle. And my slope is up 1 over 1. Up 1 over 1. Down 1 over 1. Down 1 over 1. Connect the open dots, little dashes. And we know that it's a dashed line because it's just greater than. And with it being greater than, I want to be above the line. So I'm going to shade above the line. Shade above the line in my black color so you can see it. Now, coming back to the 1. It needs to be below the line. Well, below the line is to the left side of this one. So it's going to be over here. below the line. Remember, it's all the way down to here, all the way out here. But where I double shaded, once again, is the area that satisfies this inequalities, this system of inequalities. So all of these solutions right out here make this inequality true, right out there. Okay? You could always test it, finding a point out here, and plugging them both in. Alright, let's move on. Make it a little bit more difficult because it's in standard form right now. And in standard form, we need to move it into y equals mx plus b. So, I'm in standard form, the way it's written currently, x minus 2y less than or equal to negative 6, and 3x plus 2y is greater than negative 2. Now remember, I need to write it in standard form, slope-intercept form, which is y equals mx plus b. I need it in this form and out of standard form to be able to graph it. So the first one, and I'm going to label them again, A and B, okay? The first one, A, and I'm going to label it so you can see which one I'm doing. X minus 2y less than or equal to negative 6. Well, I know that I need to move the x to the right-hand side of the inequality, so I'm going to subtract x from the left side and move it to the other side. So this becomes negative 2y less than or equal to a negative x minus 6. Well, I know that y is on the left-hand side, but it's not by itself yet. It still has negative 2 attached to it. So I need to divide by negative 2, which means I'm going to divide every term by negative 2. So that leaves me y by itself. Well, remember that if I divide across an inequality by a negative, that I have to flip the inequality sign. So I just flip the less than or equal to a greater than or equal to. And then a negative x over negative 2 becomes a positive 1 over 2x. Because remember, there's a 1 in front of the x that we typically just don't write. And then a negative 6 divided by a negative 2 becomes a positive 3. So I know that at 3, my y-intercept is a positive. My slope is 1 over 2. Up 1 over 2. Up 1 over 2. Down 1 over 2. Down 1 over 2. So I know my line is a solid line because it has the equal to bar underneath. And there it is. I also know it's greater than, so it would be shaded up here. And I'm going to do more of that here in just a second. The second one, B. That is 3x plus 2y greater than negative 2. Just like the other one, I need to take the x to the other side. So that leaves me 2y greater than a negative 3x minus 2. Divide by 2, divide by 2 across every item. That gives me y greater than a negative 3 halves x minus 1. Negative 2 divided by 2 gives me just a negative 1. From here, it is a greater than, so I'm going to have an open circle at negative 1. Negative 3 over 2, so I go down 3. 1, 2, 3 over 2. Up 3. 1, 2, 3, but go to the left. There we go. Up 3, 1, 2, 3 over 2. And I could dash my line from there, put some arrows on it, and now I am greater than or above that line. So above that line is going to be out here and out here above that line. Okay, above that line. And then I also want to finish shading the original one, my first one. Holy cow. Let's get that corrected. Get that blue off of there so that it should have been all black. Just grab the wrong pen. And right there, where I double shaded, or where I meant to double shade, which is right in here, This is the area where my solutions that would satisfy this system of inequalities makes both of these true statements. Okay? So it'll be right up in there. All right, let's get you one more. I think one more can get us. We'll leave number 7 for maybe class time. If anybody's still struggling, we can do number 7 in class. So this will be number 6 in our last one. We are in standard form again. X minus 3y is less than or equal to -3, and x plus 3y is greater than 9. That is in standard form. We want it written in y equals mx plus b form, or what we call slope-intercept form. All right, label my 2 lines so we know which ones are going to be which. And away we go. I need to move line A into slope-intercept form. So I'm going to take the x and I'm going to move it to the other side, which means I need to subtract it. It gives me a -3y less than or equal to a -x minus 3. Divide by -3, divide by -3, divide by -3. Every item gets divided by -3 in this case. Since I divided by -3, what do I have to do with the inequality sign? You're right, I have to flip it. So it goes from less than or equal to greater than or equal to. A -x divided by -3 becomes a positive 1/3x. And a -3 divided by -3 is a positive 1. Since that is an equal to bar underneath the greater than sign, I have a closed circle at 1. And my slope is 1/3. So up 1/3. Down 1/3. Draw my line. And I'm going to be done for the second. I'm going to be greater than, so I'm going to shade above here in just a minute. The second inequality, x plus 3y greater than 9. Once again, I need to move my x to the other side, so I subtract it, leaving me 3y greater than -x plus 9. And I need to divide by 3. This gives me y greater than a -1/3 x plus 3. 9 divided by 3 is just 3. Okay? Since I have just a greater than symbol, at 3 I have an open circle. And my slope is down 1/3. So down 1/3. Up 1 to the left 3. And I can start dashing my line to connect those open circles. And now I want to be greater than this. So I can go ahead and shade this greater than or above the line. Above the line. Okay, above it. And I want to be above this line as well. So I can go above this line. Notice where I shaded both colors, the black and the blue, which I'm going to shade in as red so you can see it more clearly. This area right in here becomes my area that makes both inequalities true statements, or in essence, my solutions to these inequalities. All right, this has been 4.38 notes. Hopefully you enjoyed it. Ask any questions. Happy to answer them. Have a good day.